Hi everyone, welcome. This is live. I hope we get a good amount of kids joining in, but even if you don't join in, that's perfectly fine. Hi, I hope you guys can hear me. Am I loud enough? I do not know if I am. How the stream is. Yeah, just checking all the controls, everything working. Sorry, I'm taking from my home, not the office, so the furniture behind me is just home furniture. Okay, hi Hajra, what's up? Yes, Hajra Javed writing. Hi, this is Hajra. All right. Okay, so as people keep joining in, hi, good afternoon. I think good evening in some most parts of the world, and the paper is tomorrow in the afternoon. Yes, absolutely. And isn't this the case? Okay. Is the streaming fine? It looks good. Yep. Okay. So what I've done is I've taken select questions of the 2024 papers, the three variants, paper 21, paper 22, and paper 23. Select questions from all of them, the ones I'd like to try out with you. Okay. And then, so I tend to want to go over some of the things that these papers will highlight. Some of these questions, these are all from the 2024 paper. Here's what that looks like. Maybe if you guys can see it. I don't know if you can. There you go. Yes, that is the case right there. Okay. I have a chat bubble also. My name is D. Okay. I feel like I underperform. Yes. That's pretty cool. Okay. I don't know. It's just brown. It's not pretty cool. So you feel like you might underperform. That's okay. I don't think you will, but I think it helps to also believe in yourself, right? It's in biology and medicine, they call it the placebo effect, or maybe something similar. Because you think you've taken a medication, you tend to get better already. So here you gotta manifest. If you think you are going to do bad, you definitely are going to do bad. So you got to think that, no, I'm confident, I'm smart. If you don't have faith in your abilities, how are you going to ask the world, which is your university admission officers, your boyfriends or girlfriends, your husbands or wives, and or your bosses to ever have confidence in you? If you want the world to start believing and having confidence in you, it starts from you first. I don't mean overconfidence, I mean just general confidence. Yes, okay. Reality check with some confidence would help. Yes, I predict that you're going to get 2024 November paper 22 variant. That's exactly what you're going to get. You're definitely going to get one question on organic chemistry. There will be some writing in English, some chemistry, some formulae of elements. That's my prediction. Yeah, and my glasses are dirty, so let me clean them up. So that's what we have. I'd love to get started, right? And on this paper, I won't write the answers for every single thing, but yeah, for most things I will, okay? Yes, some things I tend to not want to write the answers because kind of like, what's the point, right? What is the point? That's what I would ask. Yes. Anyways, like for example here. So, how do we start this off? Okay. What did I say about prediction, Ryan? Are you sure you want to hear it? Because it's kind of lame. I was making a joke. The prediction is you're going to get the paper 22 variant in most of your regions. You're going to get a question on organic chemistry. You're going to get to write answers in English. You're going to get a space where you have to write your name, or if it's already written for you, that kind of stuff. It was all nonsense. I don't know why you took me seriously. It was just, there's no prediction. Please. We can't predict anything in the world. What's wrong? And even if we can, I don't wanna. Okay, so I'm gonna start teaching now. Okay, and so yeah, is that okay? All right. Okay, I'm just getting everybody psyched. Your paper is yes. Well, I know that's what dad jokes are. The ones that are not funny. Yeah. He says, not funny, bro. Not funny, bro. Well, okay. Anyways, so let's start. Okay. So we'll go on till as much as you guys want to go on, and then we'll stop. All right. So now let me shift off to now getting your attention off to the papers. So this one is the first question in the 2023 variant, right? Yeah. All right. And we're going to start off with this. Okay. So yeah, I got to move a little this way. Yes. And then start. And I'm going to start writing the answers. And when I clip myself, I will turn my face off for a bit in between. Okay. So let's begin. That works for you guys all? Okay. So where does the first question start up from? What is the first question really asking? It's asking here, this is the one from, like I said, the 23 variant. It's asking is, explain the lack of reactivity for nitrogen. Now you see, this is for worth 2 marks. They probably are looking for 2 reasons, right? And the lack of reactivity comes from 2 reasons for nitrogen. One is the fact that it's nitrogen triple bond is very strong. Now when you have a very strong bond, it's very, very hard to break. So you can say this bond is very strong, it required lots of energies to break it, therefore high activation energy, less reactions. But just because the bond is strong doesn't mean it won't break. Another reason why it doesn't react is because the N2 molecule is non-polar. You see? Now you might say, you might remember this triple bond molecule from organic chemistry. And it is a pretty good reactant. You know why? Even though it has a strong bond, but it's still, it is reactive because it's got polarity. It's got polarity. Very reactive. On the other hand, N triple bond N is non-polar. So it doesn't really take part in those reactions where it becomes a reagent, and it won't even break apart because there is no it's hard to break it also. So in HCN, you don't break the C triple bond N, but you can get the C to react, like the C ion. Remember the Cn minus ion has these lone pairs and attacks as a nucleophile. So you can have a strong bond and still be a nucleophile because it's charged or polar. But N2 is non-polar and has a strong triple bond. So those are the 2 reasons. I'm taking some time here because it goes to the core of your, core of your understanding of molecules. Okay. Anyways. Alrighty. Now, okay, what are we going to do next? So I'm going to scroll down. It says, so covalent bonds can have sigma and pi bonds. So the N triple bond N is in fact a sigma bond and a pi bond on top at the bottom and a pi bond in front of the screen and behind the screen. So you know, it's like that, in front and behind. So a triple bond is actually 1 sigma and 2 pi. And the sigma has p's overlapping head on like that. 1 p with another p. Head on overlap. While the pi bond is a sideways overlap. How the bonds overlap? Head on. Where it is sideways, or better known as lateral. I don't think they want us to draw. They just want to write the English for it. Okay. So you can say lateral overlap of adjacent p orbitals in the same plane. Okay. Or I can also draw it and write the English for it. Okay. That's the first part of the question. Alrighty. Then, so this is easy stuff, but this is where you want to get the marks. You really want to get the marks and not lose them. Okay. It's important that we get that. Okay. Now the next part of the question says a sample of aluminum reacts with chlorine. Now when I know about aluminum with chlorine, it makes AlCl3, which if we heat it long enough becomes Al2Cl6. In both cases, aluminum has a +3 oxidation state. That's what it is. And if you think about the chlorides of period 3, they are NaCl. Let me write them down. They are NaCl, and what else? NaCl, MgCl2, AlCl3, SiCl4, PCl5. And the oxidation states for these guys tend to be the number of outermost electrons. So what determines the maximum oxidation state of period 3 elements? You might remember SF6 also, that's +6 oxidation state. And what is that? So what is the maximum oxidation number? It comes from the number of outermost electrons, or the number of electrons in the outermost shell, or it comes from the number of electrons in outermost shell. These are easy parts of the question. I think everybody should be able to get these right? All right. So if there are any questions, please feel free to throw them my way. I'm going to go on to the next part of the question also while I wait for your questions. And I want to do this question only because it kind of gets us to revise some of the period 3 stuff, right? So here in the next part of the question, you got aluminum oxide, which is, I know it's ampho. I've got phosphorus oxide, that is acidic. And so when I add NaOH, it will react with acidic oxides and it will react with amphoteric oxides, right? Yes. Outermost electrons are valence shell electrons, the same word, the same meaning from two different words, all right? Absolutely. Okay. Now they want us to write the equations. Equation is what I'm saying. Yes. Yes, yes. Now what are these equations now? So now the one with the P4O10 is easy because that with NaOH makes the phosphate ion with sodium Na3PO4 plus H2O. And since it's Na3PO4, you need 3 NaOHs. And you got 1 P, so you need 4 of these. So that means how many NHs you need? You need now 12 of them. So 12 NaOHs. And then check the oxygens. 12 plus 10 is 22. 16. So I need 6 here. And H is 12. H is here. 6 times 2, 12. And that's how I balance it. Yeah? Now with Al2O3, it is slightly a little bit more than just that, you know. You got to understand that Al2O3 is going to make this anion. Which one? The AlOH 4 times 1 minus anion. Okay. Now, because Al is 3 plus OL is 1 minus 4 of them. So they make the final compound NaAlH4. If you remember that, everything else can be balanced. So you got NaOH and you got Al2O3. And you can also add in water if you need to. But first let's balance the NAs. So I only need 1 Na. I have 2 Als here, so I put 2 there, which means I got to put 2 NaOHs. So I'm just going to balance it out. I don't need to learn it. I just balance it out. Okay. So 2 Nas there, 2 Nas there. Al2, Al2. Now comes the big moment of hydrogens. I've got 4 times 2, 8 hydrogens. But I've got only 2 here. So I need 6 more. That means 3 waters. Because that's 3 times 2 is 6. Whenever you're missing something like H and O, you can add water. Okay. So I'm thinking I'm answering the next part right here. So my bad, I didn't read the question. So I'm going to just move these things down and then continue my question because I wrote the equations down. Okay. And then I'll write the states on top. So I got this going for me and I think it's balanced now because I've got 2 oxygens and 3, 5 and 3, 8. 4 times 2, 8. So I balance the equations first and then what do they want? Okay. They're at room temperature. Both of these are like obviously metal oxides are solid, but P4O10 is also a solid because it has a lot of electrons, which makes it having a much higher melting point. Hence, it's a solid at room temperature. Apologies for mixing up the 2 parts, but now you have it. Absolutely do. Yeah. No, the equations are for 2 marks. The solid state is for 1 mark. And these equations can be learned, but I do a bad job of remembering these, so I always just balance them on the spot. Yes, not all marks are created equal. Some marks can take 10 seconds, 30 seconds. Some can take 2 minutes. And just, this is important, guys, important. Just because there are given marks, not every mark requires the same amount of time. Okay, yeah. Now is it there? Sorry about that. It's back. Sorry. Okay, I'm back. So the oxidation number in this question for calcium is +2. So it's a 2+ ion. Silicon is unknown X, and oxygen we got 3 of. Each oxygen we know is -2. So the math is +2 for calcium, X for silicon, and 3 of oxygens, and the compound is 0. And you do the math, it comes out to +4. So the oxidation rate of silicon is +4. Absolutely. And calcium oxide can be found. Now calcium oxide from calcium carbonate, by the way, that's the name of the reaction is thermal decomposition. Composition. It's probably the easiest mark anybody can get. It's calcium carbonate becoming calcium oxide plus the lovely carbon dioxide. Yes, absolutely. All right. Somebody got some cool glasses going there for themselves, right? All right. I like those. I like those. Anyways, moving on. What do we got? That's the first question. Now the next, the one I've kept is the same paper, question number 2. Okay. Yeah, I don't think I'll be doing one for paper 5. I'm just doing one for paper 2 and paper 1 this time around. Yeah. Paper 1 and paper 4 I would, yes. So paper 4, yes. Okay. You can't see the whole working. They're not much working, boss. Here. The working for what? The oxidation state calculation. It's calcium, silicon, oxygen. You add them to 0. Is that what you want? Yeah. Yes, we'll be doing a paper 4. I will be doing a paper 4 session. Absolutely. All right. And now, okay. Now, moving on to the next part now. Next question. So this question is the second question in the same worksheet. Okay, in the same paper, sorry. So the reaction shows different conditions for the 3 equilibrium mixtures of A, B, and C. Of 3 equilibrium mixtures A, B, and C. You've taken initial moles of nitrogen, oxygen, or nitrogen and hydrogen, all 3 in the same ratio. Between A and B, you're keeping temperature the same, pressure is the same, you're just adding a catalyst, right? So some conditions only increase the speed of reaction, while other conditions increase the speed and also the shift the equilibrium position. Now catalyst is only the one that increases the rate. So for example, B, I can look at this. For this should be 58. And in C, you have a higher temperature. Now what does a higher temperature do? It increases the reaction, but it also favors endo reactions. And here the forward reaction is exo. Do you see that? The forward reaction is exo. So now, therefore, at a higher temperatures, this will favor the backward or the reaction that goes to the left hand side. Okay. Love from, okay. I have no clue about travel and tourism, Hans. All I can tell you is that the pad thai in Bangkok is the best. And what do I say? The best tacos I've had in LA, and The best Nihari you're going to find in Karachi. That's what I have. Love from Mauritius. Yes, I do want to go to Mauritius someday. So it does look cool. Yep. So now here, so it favors backward. Therefore, y will be less than 58. That's what's going to happen, right? Okay. Now, describe and explain the change if to the percentage yield of B. So the describe and explain for 1 mark. Yes, a lot of writing for just 1 mark, right? So what do I have next? So what do I do? First of all, is there any change? There is no change to the yield. You know why? And you can write that. I'm not going to write it, by the way. Yeah. The answer to the question is there's no change because catalysts do not affect yield. They only affect the rate of reaction. Yeah. No yield, only rate. All right. That works. Yep. Thank you, Rubarashi. I am. I'm gonna leave this there for a while. He's calling me the best, so I gots to, you know. I gots to say something. I gots to say something. I gots to say something. Dun, 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 dun. Okay. Yeah, there you go. Yay! Okay, moving on. Then, okay, I'm just having fun. It's been a while since I've been on the YouTube live. I forget how liberating it is because everybody from anywhere can just be here. Okay, moving on. Then it says here, the next part says, describe a change to the yield in C. Now, we already discussed this. So, in C, due to higher temperature, as temperature increases, it favors which one? Endothermic. Therefore, equilibrium is shifted to the left. What does that mean? Therefore, yield will decrease. Yes, absolutely. Yes. Enough of that. What do you call it? What do you call that? Loving yourself thing. Yeah. Okay. I agree. Yes, the best kunafa. Actually, I've had some great kunafa in Dubai also. So I've got to go to Jordan to find out. It might be, you might be right. You might, sir, be right. I got to come to Jordan. You know, someday. Yes. Okay, moving on. Okay, all right. Then next part. So far, so good, everybody. It's pretty okay. I don't think it should be very difficult to understand this. Yeah. Now, describe and explain the change to the rate of the forward reaction in C. Now, here you need not refer to the Boltzmann distribution. They've even said that. Oh my God, they're like, come on, open your mouth, spoon feeding you the answer, what you need to write. So you just have to mention in other terms. So what happens is, as temperature increases, the rate increases. And why? As more molecules have greater energy and a larger proportion of molecules now will have energy greater than what? That's the game. The proportion of molecules that have energy greater than activation. So the proportion of molecules that have energy greater than activation is more. If that's more, therefore greater proportion of successful collisions. Okay. So now, so therefore, more molecules have energy greater than more molecules have greater energy, and a large proportion of molecules will have greater energy than sorry, I should speak slower. Because energy of all molecules increase, more molecules have energy greater than activation. Therefore, there is an increase in successful collisions, also known as effective collisions. Okay. Therefore, the rate of reaction increases. Capish? Capish. All right. Any questions so far on this? I can go. And then there's a KP calculation. So just checking if there are any thoughts on this, any questions before I move on. Yes. Rate is per unit time. So yeah, I've already mentioned rate is faster. So yes. Collisions per second. Yes. It's more increase in success collisions per second. Yeah. Or per unit time. You're absolutely right. Sorry. Okay. If the question came in this, I can do this. I don't think it's in here. There is no m+1 ka graph that is needed. In fact, there is no m+1 graphs that are needed. It's just that you have to look at the ratio of m and m+1 and find the number of carbon atoms from that. That's it. No graph needed. Okay. So can we then go to the next part of the question? Next part of the question, the KP part, right? We still have a lot of questions left here. Okay. Okay, so I'll move on to the question, right? So the next part of the question is write the expression for the equilibrium constant Kp that they want in partial pressure terms, right? So what is Kp? It's the partial pressure of, the partial pressure of ammonia, that thing squared, dy, because that's on the right hand side, and then the partial pressure of nitrogen into the partial pressure of hydrogen cubed. And the units, now did they give the pressure in atmospheres? I believe they did. So there's atmosphere square on top, and you got the atmosphere into atmosphere cube at the bottom. And when you simplify this lovely thing, you're left with atmospheres -2. So the units are atmospheres -2, and that is the Kp expression. Yeah. Agreed? I think the question didn't have pascals. If I scroll back on top, the pressure in the question is given in ATM. If you notice that, not the ATM money machine, the atmospheric pressure, right there on top. Yeah. Okay. And then it says the equilibrium mixture D is made when 1 mole of nitrogen and 3 moles of hydrogen added to a sealed container at a certain temperature and a pressure, and the mixture contains a certain amount of ammonia. Okay. Now you want to find the mole fraction of ammonia. What you rather have is the ice table, right? Initial, change, equilibrium. So the initial moles were 1 and 3 and therefore 0. But at equilibrium, ammonia is 1.16. That means its change was made 1.16, which means the other guys are lost. And the change is in the ratio of the equation. It's the ratio of. That's important, right? So what do I have here? So if 1 reacts with 3 to make 2, and something reacted with something to make 1.16, what is half of 1.16? I should have had my I have my calculator. Yes, lovely. I forgot these things still exist. You know, it's 0.58. So this fellow is 0.58, and it reacts with 3 times that. So 1.74. So what's left at equilibrium? 1 minus 0.58. 1 minus 0.58 is nitrogen is 0.42 left, and that's 3 minus 1.74 is 1.26 left. Yeah. So the mole fraction of ammonia is the moles of ammonia over the total number of moles, which are 0.42 plus 1.26 plus 1.16. Remember, mole fraction is the sum of all the moles in the mixture. So that's 2.84. So 1.16 divided by 2.84. What do I get? 1.16. Don't leave it as a fraction like this. They don't mean literally write the fraction. They write find the value. I get 0.40845. What if I round this off to? For three significant figures, 0.408. Because the next digit is 4. So that's for 3 sig fig. Alright? So far so good? Let me know. I'll scroll down. Any questions? Okay, and the next part, while you guys are taking a look at this, it's saying the mole fraction of N2 in another expression is this, in an equilibrium E, and they want the partial pressure when this is, the mole fraction of N2 is this in a new equilibrium mixture. And so that's the mole fraction, that's not the moles. Remember, partial pressure of anything is the mole fraction into what? Into total pressure. So I don't even know why they give this. This is so easy. This into 1,000 atmospheres, which should give me 625 atmospheres. They've already given the units, so you just write the value. All right, easy stuff. I want to get to organic soon, so yeah, I think a couple of organic questions coming up. I think there's some questions on the next page is about pollution, and then I'll move on to the questions on organic chemistry, right? So any questions, and I'm going to just move on. I can scroll down. There's easy stuff. If there are any questions, I'll scroll back up to answer them. Then it says here, when oxides of nitrogen escape for 3 marks, these are 3 easy marks, they may be involved in formation of acid from sulfur dioxide. Remember, sulfur dioxide becomes sulfur trioxide, which becomes sulfuric acid. And nitrogen's oxides help us convert convert SO2 to SO3. So now, these are catalysts in the mixture. This group is a catalyst, and the reason why they call a catalyst is because they're regenerated. For example, either you can start from NO and make it into NO2, and then the NO2 can react with SO2. I wanted to use a different color and it didn't come. So with SO2, it helps convert SO2 to SO3, and the NO2 becomes NO. And then it goes back up to the above equation and becomes NO2 again. While the SO3 reacts with H2SO4 to become SO3 reacts with water. What's wrong with me? To become H2SO4. That's what it does. Yeah. And this is pretty easy, right? It's easy. So you can write this in English. You can say, give the equations, and you can say the NO is regenerated at the end. Therefore, they are a catalyst. Now you might say, well, Bilal, why don't we start with NO2? You can start with NO2, because NO2 then becomes NO, and then, so if you think of this as equations 1, 2, and 3, either you can go in the sequence of 1, then 2, then 3, or if you're starting with NO2, you can go equation number 2, then 1, and then 3. So the NO2 becomes NO, and the NO becomes NO2 back again. So whatever reagent you have, you can start off. If you only have NO, you first make it NO2, and then it becomes NO all over again. But if you have NO2, it first reacts with SO2 to become NO, and then it finds oxygen in the air and becomes NO2 all over again. So it gets regenerated. Okay? And H2SO plus is formed by adding rain. So this comes from rain. So when the rainwater mixes with SO3 in the air, it forms H2SO4. You can write the equation, or you can write in English. Inglesions, yes? Inglesions, yeah? Inglesions. See, senor, then moving on, and then outline how NO and NO2 may contribute to what? Okay, to photochemical smog. Well, NO and NO2 react with what? With, you got to just learn this. Unburnt hydrocarbons. So, unburnt hydrocarbons from where? From your combustion engines of cars. Where if the engine is not being efficient, it will leave some unburnt hydrocarbons in the air, and those hydrocarbons in the air with NO and NO2 they react with to form these compounds are called PAN. You don't have to learn the full name. And that fellow which causes smog. It's that causes the white particles and smoggy. Okay. Gracias, senor. Okay. After. Yes. You say it's too easy. It's easy. So easy. Right? But these are some fun questions having some parts that was fun. Like this question had the table part that would throw people off because they've never seen a table where there's many equilibrium mixtures. But if you read the question, it's easy. Yes? Okay. Then, PAN, peroxy. I never learned the name. Okay. I would not want to say VOC. What does VOC stand for? I remembered, I had forgotten. What does VOC stand for? I forgot. Something. Edamame. Okay, moving on to the next question. Okay, it's enthalpy change. Okay, you know what? Skip that one also. It's getting a little boring. Okay, so there is a question on. Oh, this is nice. You know why? Because it's got some organic and some inorganic together. Okay, do you want to try this one? This is also from the same paper, 2023, paper 23, question number 4. This says, draw a diagram to show the ionic, covalent, and coordinate bonding present in the formula unit of NaH. Oh, you got to make the whole thing. That's going to be fun. So what you want to do is, yes, okay, so either you can make a dot and cross or a stick diagram, right? So if I make the stick diagram, I will first show regular covalent bonds. So ammonia has 4 bonds with hydrogen. One of them is dative and the other 3 are regular, and then the whole fellow is charged as in Cl Na plus, and that's the ionic bond between. Okay, or you can therefore separately draw the NH4 and say, well, these are ions, but you want to show the coordinate bond. What you might want to do is, like what I do is make a circle H. Oh no, I'll do a different color for H's. 1, 2, 3. Come on, why can't it be a normal circle? 4, right? Okay, so now what do? H, and what in some of them you want to do is dot and cross. You want to do dot and cross, and in one you just do dot and dot, and then you can write N in between, and then you can say, okay, go back to the normal pen like that, and then you can have Cl minus. But you can also label them, like here this is dative, which is the one I've shown with the 2 electrons, though generally they will say dot and cross. So you are okay with the one in blue, but you could also do the one in red. Okay. Oh, VOC is volatile organic bond. Hey, no. In the previous question, you've got to say unburnt hydrocarbons, because volatile organic compounds can also be, let's say, they aren't really hydrocarbons then. They could be alcohol, is also volatile organic compound, like methanol. So here I would just say unburnt hydrocarbon for the car engine. You were not going to get ethanol or even carboxylic acid from there, but some of them are Anyways, so yes, to answer your question, yeah, I won't say VOC, I would say unburnt hydrocarbons. Capiche? Capiche? Now, moving on to what? To the next part of the question. Yes. All right. So then it says an exothermic reaction occurs where NH4 plus is added to to OH. You know why? Because this is acid, this is base, and NH4 plus gives me H plus ions that combine with OH minus ions to become what? Water. The type of reaction is neutralization, or you can also call it acid base. You know, it can also be called an acid base reaction. Acid base neutralization or acid base reaction. Construct an ionic equation. Ionic equation. Okay, so basically there are two parts of the equation. NH4 becomes NH3 plus, NH3 and H plus, and then the H plus becomes water. You want to combine them because it is not a strong acid. If NH4 was a strong acid, you would get only H plus ions. But because it's a weak acid, it's going to lose the proton, and OH minus is going to gain the proton. Remember, acids are proton donors. So NH4 plus donates the proton and OH minus gains the proton. Looking at this, if they were to ask the role of this fellow is a proton donor. So it's a Bronsted acid. This is a base. And the Bronsted acid becomes a conjugate base, and the base becomes the conjugate acid. These are the pairings that I'm doing. Okay. So, all right. So if they said label the pairs, so acid 1 and base 1 are a conjugate acid base pair, and base 2 and acid 2 are a conjugate acid base pair. All right. You follow? You follow. You better follow. Yes. Oh, I know he was responding to the VOC. I get that. And that's what I was saying. Do not say VOC there. Say what there? Unburnt hydrocarbons. Please. Elevate our answers to the A levels that we are part of. Remember, they call it advanced for a reason. I know not many of you have advanced your understanding and ability, but they still like to call it advanced levels. So, you know. Yeah. Then it says here, the next part is substitution reactions of ammonia and OH minus with halogenoalkanes involve a lone pair. So what is the particle that has a lone pair called? It's called a nucleophile. It's called a nucleophile. Hi Asad. Hi Asad. Hi Asad. Hello. Okay, then suggest, the next part says what? Suggest which species are more reactive during these reactions. You gotta now suggest. It's not, I mean, nobody's learned it, but it's common sense. Because one fellow, ammonia, has only one lone pair, while OH minus ion, O has actually 3 lone pairs and a minus charge. And since nucleophiles are lone pair donors, they give up the lone pair. Which do you think is going to give up the lone pair easy? You can figure this one out. Okay, it's pretty simple. Okay, why? Because OH in this case more reactive, because OH I would say is more reactive. You know why? Because it has a greater negative charge. You might say, well, what does a negative charge do? Therefore, attract. Remember what those nucleophiles attack? The attraction of the delta plus on carbon will be stronger, because more negative is going to attack the carbon plus. It has also more lone pairs. Okay, that's the go-to answer. Obviously, it's a suggest. You don't learn this. They want you to think it on the spot. Think. Yeah? Okay. So far, so good? Any questions? Or I can move on. because we want to get to the organic part then. Okay. Then, okay, so the next part of the question, well, oxygen is more electronegative. Yes, you could say. Yes, but it's like guessing. You could say that they'll accept it, but that is in the element form. Remember, this is already an ion, so its electronegativity is already not, it's already used up in a way. So they'll accept it, but it's not the best answer. I wouldn't give it. Okay. I am so glad, Madiha, you're having fun. By the way, I like your icon. Is that a Nintendo? What is it? A Game Boy? Have you guys ever played a Game Boy before? I don't know. Game Boys were like handheld fun devices. Alrighty then. We don't have to mention. Well, the negative charge is more important than the mention in the first place, right? So up to you. Up to you. Completely up to you. But it's not needed. I won't worry about it. But you can write it. Yes. So you can say that the O has 3 lone pairs. Much easier to donate the lone pairs. They'll also be correct. Absolutely. Okay. So here I'm going to go and see the whole classes. It's BMO for redemptive time to show. No, it's Nintendo Game Boy from much before the show that you talk about. I tell you, kids these days. Okay, sorry. 2-bromomethyl propane reacts with this. Now 2-bromo, both, they're saying both occur. And remember, SN1 is 2-step. Okay. And SN2 is 1-step. So now they're saying this is already the SN1 reaction, the 2-step one. They want to make the 1-step. So how do you do this? You start off from the same. Remember, SN1 has the SN2 generally has remember, this is what I've taught in the video lessons. Every halogenoalkane can undergo SN1, SN2. Okay. It's just the one that's favored has a lower activation energy. Now you think about this fellow. You got to understand this fellow. 2-bromo-2-methyl propane. When I make 2-bromo-2-methyl propane, this is what it is. Can you tell me the kind of tertiary halogenoalkane this is? Yes, Madiha. Yes, you can say I'm wrong. Not today, because your paper is tomorrow. Tomorrow you can say that. But Game Boy came out when? Do you know? Nintendo Game Boy. It came out in 1989. Is your cartoon that old? No. Yes. But points for sticking up for me. Anyway, so this is tertiary. Remember, tertiary undergo reaction via SN2. You know why? Because they have lower EA for SN2. Which means if they now want me to draw, sorry, SN1. No. They undergo SN1. What am I saying? Primary undergo SN2, tertiary undergo SN1. Which means tertiary have a lower activation energy for SN1. So again, let me repeat. Primary halogenoalkanes undergo SN2, tertiary undergo SN1. What that means is for tertiary, the activation energy of SN1 is lower, which means if they want you to draw the SN2 activation energy, it will be higher than SN1. So this will be a higher EA. So the reaction would look like this, something like this, and I'll do it again. Like that. Now, if the molecule in question was a primary carbocation, a primary halogenoalkane, then the SN2's pathway would have been lower, like this green one I'm going to make. This is for a primary halogenoalkane, and the orange one is for a tertiary halogenoalkane. For a primary, SN2 is lower in activation energy than SN1, hence primary undergo SN2. For tertiary, they undergo through SN1, which is a 2-step process, the carbocation process, because this SN2 has a lower, the 2-step has a lower energy, the 1-step has a higher energy. That's what it is. So for each of the 2 types, the activation energies determine which one happens. And then there is an explanation of why the activation energy is like that, and that you also have to know. Okay, but here they didn't ask for that yet. Okay. Okay, yes, but okay, was for the Game Boy or for this question? I'll wait before I continue. I have a nice little video on this, by the way. Yeah. Any questions? Oh, thank you. Yes, thank you, Madiha. But you know who I want to win tomorrow? I want you guys to win tomorrow. See, I don't want to win tomorrow. I want you to win tomorrow. See, I'm getting in your good books. Anyways. Okay, Aritro says no, sir. I don't know what the no, sir is for. I'm going to wait for it. He's going to tell me. Yes, my prediction for the question is they'll ask you to solve in English, and there will be at least 2 questions in the paper. Now they want the SN1 mechanism. That is a 2-step mechanism. Okay. Yes, thank you, Serene. I never do predictions. It's a waste of time, because if I could do predictions, I'd predict how much money I'm going to make next year. I'd predict which city would I have more fun in. I don't know. Why would I want to waste my time predicting exam papers? Just because you want them? Please. Okay, so how do I do the SN1 mechanism? So SN1, you got to first draw the partial charges on this, and then the electrons from middle of the bond go to Br, and Br is lost and has a new lone pair. That's the first part. Then I hope I will make you win tomorrow. Predictions never do much. That's why I don't predict, because it's a waste of time. And in fact, it takes your energy out of. It's not like your O levels or IGCSE where every chapter comes. Here, there's a much less chance of chapters coming. So here, it's a futile effort to predict. The only reason why anybody would want to predict is to make you learn the chapters that they think you want to learn. Hence that. Anyways, that's the part. And then you are adding ammonia. Oh, tricky people. You see, they have NH3 plus. So now what you want is, you want NH3 to come in with its own lone pair, and that lone pair is transferred to the carbon. That's the next part. So C and Br have dipoles. The bond in the middle breaks to go to Br. Br is lost. Now the nucleophile comes in, ammonia, gives it here. And now this whole fellow has a plus charge, but remember, we've got to lose one H. So one of these NH bonds breaks. That has to be, because how else will you give off H plus? You have to give off H plus. It has to come out, and the 2 electrons from the bond go here, because N needs one extra electron. It gets its electron back and hydrogens, and therefore becomes neutral again. And this is how you draw the mechanism. Obviously, if this was OH minus, you would stop here. You would not need to kick out any extra H plus. Okay. Now tertiary is SN1. Yes, tertiary is SN1 is like saying tertiary undergoes SN1 reactions because they have lower activation energy. Yes, Pratt. Obviously, I will post it. And that's why do you think I am not cursing in this video? Because I like it to post. So it is going to be available for everybody forever till YouTube dies and is bought over by Instagram or Snapchat. Okay. So do we get HBr in the end? You are absolutely right, Serene. If it's not aqueous, then H and the Br. Oh, that would be better than losing the H plus, right? Yeah. So yes, you have Br and H plus. They can combine to make HBr. But you know what? They don't even care about that. They're inorganic. So who cares? Yep. Okay. But yes. And this is a secondary carbocation. Remember? For this fellow. Because they've already mentioned this is undergoing SN1. You see, you need to understand that tertiary will most always go SN1. Primary will most always go SN2. Secondary, partly SN1, partly SN2. They're telling you here it's SN1. So you will believe what they say. You know why? Because they made the exam paper. So you got to believe them. It's their exam paper. Right? So that's the mechanism. And then I will scroll down to the next part of the question. All right? So then they say identify the inorganic product that forms in reaction number figure F2. Okay. So now there is another problem here, by the way. You know what the problem is? Because somebody said, yes, we mentioned, right, it'll make HBr. So the problem with HBr is it's an acid. And you also have a reagent in the mixture. What is the reagent? Ammonia. So what do you think ammonia and HBr will do? Can somebody tell me? Somebody, please tell me. So can you say erythro? Okay, so let me repeat this again. So it is you cannot say SN1 or SN2 has lower EA. Depending on the type of halogenoalkane, they have lower or higher EA. Okay, just to answer your question, remember, so for primary haloalkanes, SN2 is one step, right? SN2 has lower EA. For tertiary halogenoalkanes, SN1 has lower EA. Okay? That's why they take place. Okay? That's why tertiary undergo SN1 and primary undergo SN2. Okay? Done? So now, basically in the next part, you got to remember that it's HBr plus NH3, which actually combine to make what? NH4Br. So that's the final product. Br. Ammonium bromide. Because it's an acid and a base reacting. Okay. Okay. You're welcome, erythro. Mahir. Give the systematic name for this organic product. CH3, CH, NH2. Oh. Okay, so let's make this out. Naughty fellows, they give us a molecule to make, right? So what is the molecule? CH3, CH, then NH2, then CH2, C2H5. Yeah, okay. So we have this. Okay. So now it's a 1, 2, 3, 4 carbon. Which organic compound? This is called an amine. And which position is it on? Position number 2. Okay. So I will call it butanamine, but the amine is on what position? Number 2. So butane 2 amine. Butane 2 amine. Okay. Oh, if you had forgotten, you'd have lost the mark. That's why they give. Not every mark is for everybody. There are some marks that are put there for the most specialist people. Second, that's why you have me for, to remind you, keep reminding you to always think of everything. Because generally they don't ask for the product form. Why are they asking here? Because they want you to think. Hey, they've got to give some questions that separate some from the others. If everybody can answer every question, they don't want that. It's like, understand the reason why we have exams. We want to create a hierarchy based on intelligence. If everybody is getting the same question right, everybody gets the same jobs, and then there's no hierarchy. The world works on hierarchy, doesn't it? So, some questions will be there for the people who are more analytical in their science learning. That's all. It's okay if you're not in one area. There are many more things that you can be good at. Okay, so Moving on, can I move on then to the next part? I can't even see, there's so much typing here. I've removed my screen for a second, you know, but if you're done, I can scroll down. So for 2-bromo 2-methyl propane, this, so propane is C, C, C and C. So CH3, CH3, CH3 plus charge. That's what we had done before, right? Just have to make that, and then identify the halogenoalkane that has a greater tendency to react using SN1. Between these two, you'd say this one, okay, you can name it this fellow, the one on the right, has a greater tendency. So you can say the carbocation of 2-bromo 2-methyl propane is tertiary, therefore more stable, therefore greater tendency to react using the SN1 mechanism or via the SN1 mechanism. That's what they're relating for. Okay. Madiha, you are absolutely right. I don't think anything in life is fair. Even the household we are born to is unfair. Some people are born in worse households than others. Is that fair? No. Some genders have, in some countries have, or we know the gender is not as powerful as the other gender. That's also unfair. So, hey, life is absolutely unfair. We try to make it as fair as possible. That's why I don't like to do certain things, because of unfair advantages. Yeah. But where I have an advantage and it's good to use the advantage, I do. Like, for example, I love teaching and I love chemistry. I have an unfair advantage of teaching this more than others. So I do more of it. Yeah. Anyways. Honey, the life lessons are the reason why I teach is to sprinkle in some life lessons, you know. All facts, no printer. I like this. Dude, you guys, I like this. I like all facts, no printer. I bet you haven't even used a fax machine ever, but you know the pun. I like it. Okay. Okay. All right. Okay. Moving on. We're having fun here. Yes. I'm such a sad guy. I'm actually enjoying a class more than anything else right now. This is the best hour at 7:30 I've had in a while, because by this time I'm just generally tired and can't wait for 9:30 to get to bed. So, at my space, it's 7:30 right now and it's been fun. So, the next question is on Hess cycle and energies. Do you rather I do that or a little bit of equilibria or organic first? Which one do you want to do? There are many questions here. Okay. And then there is one on mass spec somebody asked for. Oh. So, we're already at 7:36. Do you have a particular type of question you want me to do? I think the idea of Hess cycle was interesting because I haven't done one in a while. This was most of your papers, right? Okay, organic first and organic. I hope my scrolling has not caused you any headache. I just keep scrolling. Yeah. Organic, can I tell you something? I wish there was more organic in the paper. Organic is so much more fun. It's like Lego. It's like building blocks of life. It's like, I don't know. And it's pretty darn easy. Okay, everybody wants organic. Let's do organic, organic, organic. So now we have this question. Come on, come on. Organic question. We got organic. We got organic. And the people in my house are behind this camera thinking I am crazy. I am organic monster. Or there is no one outline. Arithro, there are so many outlines. Oh my God, how can I make it one? There is no one answer for everything. It's like you asking me, hey, just give me one type of girl I can marry. You know, there are so many different types. There's no one. You can say all girls are the same. No. All boys are the same. No. All reaction. There's no, it's like 3 box, 4 box, blah, blah, blah. So many. It is organic. Hallelujah. So now here, it says V is a shows stereoisomerism. And I have cis trans right here. I think I did this earlier already. For some people in my class online at Old Academy who were lucky enough to be in that class. Serene, wink wink, I think you were there. I am one of you. The sad part is you haven't stuck around long enough to become one of me. The ones that become one of me are the ones that come out of an exam paper saying, sir, there was not enough organic chemistry. How could they do this to us? Hey Ambar, I didn't see you. Finally I hear from you. Because you see, you can only know who's live by reading out who writes. You didn't write. So you and Serene has already seen this. You are user exam. User exam. More. What happens after your A-levels? You become user university. No longer exam. Okay. So what is meant by stereo? We all know having different same molecular formula, different arrangement of atoms in space. Same molecular formula, same structural formula, different arrangement of atoms in space. And the space, not in the space in like outer space. It's space. Okay. Deduce the number of stereoisomerisms of V. Now here, understand this cis trans can give me 2 cis and trans, but there are 2 chiral centers also, and the chiral centers are 4 optical isomers. So cis will have 4 optical isomers and trans will have 4 optical isomers. That makes 8 optical, and you explain that 2 chiral, therefore 4 optical. And you can say cis has 4 optical and trans 4 optical. Or you can just simply say it has 2 chiral centers and 1 cis trans site or cis trans double bond. You will become. Are you going to give it the 8? But you know, user exam 8 means giving it an 8th time the same exam. That's what I think about user exam 7. You're given the same exam 7 times. Okay, then it says, okay, I don't want to talk about the molecular formula, but what are the functional groups here? So there are 2 functional groups here. I've got 3. I've got the C double bond O, I've got the double bond, and I've got this. So which ones are this? This one is ester, this one is ketone, and this one is carbon-carbon double bond or alkene. So those are the 3 functional groups. Okay? Got it? Then it says here there are 2 reactions here involving V. In W, you'll notice the ketone becomes an alcohol and the alkene becomes an alkane. So both the ketone and the alkene are reduced. Now on the right hand side, the alkene is not reduced but the alcohol is. So when only the alcohol is reduced, you want to use NaBH4 aqueous. But if you want both the alcohol, ketone and alkene reduced, for alkene, remember, you will always need hydrogen and nickel. So reagent T is hydrogen with nickel catalyst, and reagent U is NaBH4 aqueous. Both reducing agents, but NaBH4 only reduces ketones and aldehydes. Hydrogen and nickel reduces both ketones and aldehydes and alkenes to alkanes. Lithium aluminum hydride also behaves like U on the right, you know, but it also reduces carboxylic acids to primary alcohols. Remember that there are three reducing agents, you know, three reducing agents. You got hydrogen and nickel, right? That's for carbon-carbon double bond and carbon-oxygen double bond. You got NaBH4, that's only for carbon-oxygen double bond, and you got LiAlH4, that is for carbon-oxygen double bond and carboxylic acid. Okay, you got to remember that. So the role for reagent T, what is the role for reagent T here? It acts as a what? Reducing agent for ketone and carbon-carbon double bond. It's a reducing agent for ketone and a reducing agent for carbon-carbon double bond. And what's the identity of U here? I just told you what is one. Which is one? NaBH4 aqueous. That is what you get. No, Amar, I just said it doesn't. I've said it like 3 times, dude. Literally, it only hydrogen and so hydrogen and nickel does both. Remember, no? That's why it's used here. I just said it right here, right there on top. Hydrogen and nickel reduces both the carbon-carbon double bond and the ketone and the aldehyde. This is November 2024, paper 22, I think. Yes. Oh no. November 24, paper 21, question number 6. That's what this one is. All right. So both functional groups in one molecule react with an inorganic reagent to form a molecule of Q and a molecule of methanol. Now methanol is right here. This guy, I can tell because this, you want this molecule to break into 2 organic molecules. Generally that's called hydrolysis, and generally happens with esters, and the ester linkage is broken, which I can point to right there. I can even highlight the linkage that gets broken, and that fellow is CH3. So that fellow becomes CH3OH, and Q is literally all of this is Q, with this part becoming COOH. Okay. Now somebody's asked for the M and M plus 1, and I'll give you M and M plus 1. Somebody asked for it. Somebody gonna get hurt real bad, huh? Somebody gonna get hurt. No, Amar, T is not. Yaar, come on. No. What is it? Dude, it can only be lithium aluminum hydride does not reduce alkenes. The only guy that can reduce alkenes is hydrogen gas. Hydrogen gas. Where have I said? I write it in the bonds also. Carbon-carbon double bond, only hydrogen gas. Carbon-oxygen double bond, all 3. That means ketones can be and aldehydes can be reduced by any of the 3. Alkenes, only hydrogen and nickel. Acids, only LiAlH4. Okay? Yes. Moving on, then Here, part 2 of the mass spec. Yes, last minute prep videos are on the platform for paper 5 for Alt Academy. So now you got this, so now 200 has a abundance of 100, and the m plus, so this is m and this is m plus 1, and they want you to find that. Now how many carbon atoms are there in Q? So 1 2 3 4 5 6 7 8 9 10 11. Are they 11? It looks like they're 11, right? What? So 1 2 3 4 5 6, oh, 7 8 9 10 11 12. This one I forgot. So if I start counting them again, okay, just 1 2 3 4 5 6 7 8 9 10 11 12 carbons. Now why does that matter? Because if I know there are 12 carbons in Q, I know that the m to m plus 1 ratio is supposed to be 100 is to 1.1 n, where n is the number of carbon atoms, that is 12. And here the height abundance is 100 is to x. So when I cross multiply, 100x is equal to 100 into 1.1 n, and n is 12. I do the math for x. What does x come out to be? 13.2. And that is the abundance of the m plus 1 peak they want here. Okay? Capiche? Capiche. Any questions? And then it says Q only contains hydroxyl functional groups. So now show the observations when they react with 2,4-D and pH. Y. Now what did Y have? Y had a ketone, remember? So it makes an orange PPT. Q only has hydroxyl is OH. So it has no PPT or no visible change. You can write that. No PPT or no visible change. Okay. Okay. That part is fun. Then under certain conditions, it says here, Q reacts with excess sodium to produce a total of this much of gas at STP. Now 1 mole of gas at STP occupies 22.4 dm3. They have this much gas. So how many moles is this? So now first of all, what gas? First of all, please, for every OH group, if you add sodium, you're going to get half a mole of hydrogen gas. This is important. So one thing is the gas is hydrogen, and 1 OH produces half a mole. I'm going to use that here, because first I'm going to do is I'm going to find the number of moles of hydrogen gas. That will be 44.8 centimeter cube volume of gas over 22,400 cm cube per mole. That's the volume of a gas at STP in cm cube. So when I have 44.8 divided by 22400, I get 2 to the power 10 to the power minus 3 moles, which is 0.002. Now if you think about it, what's the ratio of Q, and I'll use a different color now, Q to hydrogen? In this case it seems to be 0.002 gives me 0.002, which is 1:1. So that means 1 Q gave me 1 mole of gas, but I know that 1 OH only gives me half a mole of gas. Okay. So how many OHs do I have? Because I'm getting 1 mole of gas, it must be 2 OH groups. Because if there's only 1 OH group, 0.002 moles will make 0.001 mole of gas. But we got double as much gas. So we must have double as much OH. Okay. This is mole calculation, not even organic chemistry. But yes, knowing this reaction helps. For every 1 OH group, you get half a mole of gas is released. Which gas? Hydrogen gas. And then using the table, the difference between Y and Q. Okay, let me see what's Y and Q. So Y and Q, what's the difference? Q has acid, which is COOH, while has an OH from the acid. But what Q doesn't have is what? What will it not have? Okay. Because it says here, oh, they told you something about Q, didn't they? They said Q only has hydroxyl. So you know Q has OH of carboxylic acid. No. Is that what it is? Oh, we don't even know it has that, because we know it doesn't have a carboxylic acid, it has a hydroxyl functional group. Sorry. They're saying the only functional group Q has in this question. This is why I don't read properly. It says here, where was it? Sorry, let me just stop scrolling for a second. And it says here, this part is so important. So Q has OH hydroxyl functional groups. Okay. For OH to H, the ratio is always 2:1. For serine, for a hydroxyl OH groups in acids and alcohols to hydrogen gas is 2:1. Yes. And so here what you'll say is that Q has OH. So Q has this, while Y was an ester. So Y had this. So you'll say there will be a absorption for Y for this, and there'll be an absorption for Q at this. Literally, you'll say Q, the IR for Q will, you see this one, you'll say for the IR for Q will have an absorption at this corresponding to the hydroxyl functional group, and the IR for Y will have an absorption at 1710 to 750 for the CO double bond in the ester linkage. That's literally what you will write. Nothing else is needed. Honest to God. For Q, that's what you need here. All right? I did finding the ratio method, Amar. What else did I use here, by the way? How did we get the equation? Is how we got the ratio. 1:half. All right? Okay. So this is the last organic question I had. I think it's time for a wrap. I think it's next is what you guys can spend time studying on your own now. I think I can do as much as I can in an hour and a half. And see, that boomerang tells me that I have done the questions I intended to do here. I hope this session has helped you. It should highlight to you what you might want to revise. Your paper is obviously tomorrow, second half for most of you in the zone 4 region. If there are other zones here, I'm glad we are more international this year than even before. We've got kids from over 60 countries. We had some kids show up here from random countries also. Random meaning countries I've not even been to yet, which I want to go to. So, yes. At this stage, I will bid you goodbye and good luck, and hope and pray that you do as well as you've deserved and you have worked hard. Okay? Because only hard work and good work should be rewarded. Now, if every random person is rewarded for doing nothing, then it'll just start seeming like a grade is a waste of time. Okay? All right, guys. Thank you so very much. I also really enjoyed this. Not because only that I'm teaching you, but because I have a big fat camera here. I have one of those screens showing my face here and here and here, which is why I keep looking. And I realize this light is flattering. So I just got to look at myself for more than an hour. Anyways, this was fun. You guys were fun bunch. And stay tuned. I'm going to do a class similar to this for paper 4 for the November exams. All right. For those of you who have Chem paper 4, a class is coming up. I believe we also have some more coming up for math and physics also. Yeah, it's last minute tip for P2. Keep learning, revising, reaction. Just keep reading reactions. Breathe, sleep, eat, reactions. In the morning, get up, eat, breathe. There's no last minute tip. This was the last minute tip. Any more last minute is get 7 hours of sleep. Guys, I cannot tell you how important sleep is from athletics perspective and performance perspective. Your brain is going to function slower if you don't have sleep. So you can learn all you want, but if your brain is half dead, it's not going to produce the thinking you need to produce. Okay? Ciao. Bye-bye. Sayonara. And if you have all night long to still revise, you got 120 hours of my video lectures online. Watch them at 25x. You can finish them in one night, I tell you. Bye-bye.